Today is Wednesday, November 11th. It's Veterans Day 2015. If any of you have family members in service or previously in service, make sure you tell them thank you and happy Veterans Day, everyone. All right, let's get on to some trig. We're looking at graphing cotangent, tangent, secant, cosecant, and if you're listening to this, there's still free cupcakes. All right. Okay, so let's take a look at graphing some of these graphs with the secant, cosecant, and how does the period get affected? The period gets affected the same exact way as the sine and cosine. You're taking the period, which is 2 pi, and dividing it by b, and that's your new period. And you're going to do the same thing with units, divide it by 4, and get your slash marks. However, for the tangent and cotangent, you're going to remember the period is actually pi units. That's it. It's not 2 pi. So for the tangent and cotangent, your period starts at pi, not 2 pi. Therefore, be very careful on that number right there. There are a lot of mistakes that get made because you forget the period is pi instead of 2 pi for that. Star it, make it obvious, notes are in front of you. Don't make that mistake. Let's go to one more idea on this, which is the A. It's not the amplitude because for both of these, there is no amplitude, right? There's no minimum or maximum value. So what the A really does is you can think about it in terms of slope. Like if you had y equals mx plus b, when that m goes up higher, that means it's a steeper slope. It's the same idea as for the tangent or cotangent. As your A gets larger, it just makes that graph steeper. As it gets closer to 0, like 1 over 100, it makes it very narrow. Still going through those middle points. Y equals 3 cosecant 1/2 x. Do the same exact thing as you did yesterday. Instead of graphing this, we're going to think about graphing the sine graph. I'm going to put my dashes in, and then I'm going to graph the reciprocal function cosecant x off of it. All of this data right here is going to be off of y equals sine 1/2 x. Amplitude is going to equal absolute value of 3, which is 3. Period is going to be 2 pi divided by 1/2, which is my b, and that ends up being 4 pi. Units, I take my period and divide by 4, and that's going to end up as pi. At this point, I want to graph out that sine graph, so I'm looking at 3, -3. I'm going to remember, I'm going to dash the line because it's not part of my graph. And I'm going to start with my units, which is pi to 4 pi. Sine graph, I want to remember what's my general graph. My general graph is going to be starting at the middle and going up. So now I can start at the middle and go up. I'm going to put points in, and then I'm going to go ahead and dash it. Once you dash it, you're now going to focus on the asymptotes. The asymptotes are going to be where it crosses 0, so you're going to draw those in. Still, these are not part of the graph. When the sine graph goes to 0, this cosecant graph is going to go to infinity from the positive side, so it's going to go up and up. Similarly, since it's going to be negative, closer to 0 from the negative direction, it's going to go towards negative infinity, so it's parabola down. Now that's one complete cycle of y equals 3 cosecant 1/2 x. That's really nothing new. You're just adding the parabolas and the asymptotes to it. This is new. Y equals cotangent 3x. And again, what I'm going to do is look at what is my amplitude. My amplitude here is that it does not exist because there's no min or max. The period is going to be pi divided by 3. Students will want to do units on this, but there's no reason to do units on tangent and cotangent because you're not dividing it into sections of 5. So at this point, what I want to do is think about what is the general graph of cotangent. The general graph of cotangent is going to be where I have asymptotes here. And I think about from 0 to pi over 2 is positive, so I know it's going to go in the direction like this. And so that's giving me guidelines on how to graph this. Again, I'm not looking at any table. I'm just adjusting it. My new period is going to be pi over 3. Pi over 3 is going to be where I want to mark this one right here. Notice this graph at the origin is the y-axis. It's starting from the y-axis. I'm therefore starting here at the y-axis. That's not going to be the same for tangent. So if it says graph 2 cycles, I'm going to want to go one further. So it's going to be 2 pi over 3. It's positive. The design looks the same, so it's going to look something like this when we are all said and done. And it's nice to put in the midpoint here so you know where it crosses. That'd be half of pi over 3. Pi over 3 times 1/2, pi over 6. This would be 2 pi over 6, and this would be 3 pi over 6. It's often is the case that you just keep this in non-reduced form because it's easier to follow, easier to add the numbers. The last one that I want to do is a tangent graph, and I'm going to look at something like y equals negative 3 tangent pi x. Because it's handled differently. And so to do this one, we're going to go through that same process. Amplitude does not exist. I'm going to do the period, which is going to be pi divided by pi, which equals 1. Units I don't care about. I want to draw the tangent graph to help me think about the way the general one looks. I'm going to remember that the asymptotes straddle the y-axis, going from negative pi over 2 to positive pi over 2, and therefore it's positive from 0 to pi over 2, so it's going to look like this. However, if I really think about the negative tangent graph, the negative tangent graph is going to be reflected about the x-axis, which means now that it's going to look like that. So the red one is my focus, not the black one. Now, when I go to draw this for the real one, I'm going to look at the period. Now watch very carefully what happens here. On this graph, the point of interest is going to be right at that origin because that's where I want to shift over. It's not the asymptote like it was in cotangent, it's the origin. I want to shift that point, it's called the inflection point, either left or right. And so when I have to shift, which is going to be the next lesson, but that's what I'm thinking about. Now, on this one, it was pi, so I went to the left pi over 2 and to the right pi over 2. On this one, it's a period of 1, so the asymptotes that I have to draw in are going to be left and to the right, equally spaced. Meaning the left is going to be at negative 1/2, because it's half of 1. And on the right side, it's going to be equal to a positive 1/2. That gives me a full period of 1. Once you have that, it's the same exact way that you would graph the general one. So I know that it's going to look like this. And if I were to continue this for 2 complete cycles, I would add one period to 1/2 and get 1.5 or 3/2, draw on another asymptote, do the same exact pattern as that one. And this would be 1 at that intersection. That should give you an understanding of amplitude and period in drawing cosecant, secant, tangent, and cotangent. The next lesson is going to be on phase shifts. So we're no longer going to be starting at the origin or the y-axis. We're going to be moving that in one direction, and that's going to be my starting point.